Okay, so let's go ahead and video the quiz here for Unit 4. Newton's laws of motion and forces is what this unit is over. I'm also going to take pictures of this quiz. That way you can print it out, you can have it, you can review it, look over it. Okay, so hopefully it's helpful. First question here says here, given a block with two applied forces are as shown here. What is the net applied force? The word net force means the answer, right? So overall, what's going to happen? Is it going to move to the right? Is it going to move to the left? How is it going to happen? So I've got a vector over here moving to the right, 8 newtons. A vector moving to the left, 3 newtons. I only have it here in the x component. I don't have the y component. Since I only have vectors here in the x component and they're opposite, I'm going to subtract. And that's all you have to do. So is it just that simple sometimes? Sometimes, yes, it is. So we're going to get 8, take away 3. Why is that? Because we do not want a negative value. We want the difference. We're not looking for negatives. Okay, now 8 take away 3 equals 5. Now I can look to see which one of those two vectors is larger. This is my larger vector, so it's going to be 5 newtons to the right. That's going to be the winner. So my correct answer is 5 newtons to the right. Let's keep going. If an object is moving at a constant velocity with no applied forces, well, what's going to happen? Well, Newton's first law of motion says an object in motion stays in motion, an object at rest stays at rest, unless an outside force acts upon it. And this tells me right here that there's no outside forces acting on it. An object in motion will stay in motion. It will continue to at a constant speed. It will not speed up. It will not slow down. The majority of the students actually miss that question. Where does this question come from? Newton's first law of motion. An object at rest stays at rest. An object in motion will stay in motion if there's no outside forces acting on it. The next one, given this block, it has an applied force here shown. What is the net applied force, right? Means what's the answer? I have 5 newtons moving to the right and then a vector of 5 newtons moving to the left. I only have the x component. There's no vectors in the y component. So in this case, it's pretty simple. Since they're opposite, all I'm going to need to do is subtract. 5 take away 5 equals 0 newtons. Okay. The next one. Newton's first law is also called the law of inertia. It says here that 2 students wearing roller skates stand and face each other. They both push at the same time. The first student experiences a net force of 8 newtons. The net force experienced by the second student is going to be what? So I've got 2 students and they're on roller skates. Another student is on roller skates. There we go. Now they're going to push on each other. And when they do push on each other, we know that one is going to move this way, this one's going to move this way. Now let's just say that this student pushes with 8 newtons of force. What is the force experienced by this student? How many newtons? Well, Newton's third law states that for every action, there's an equal and opposite reaction. One more time. For every action, there is an equal, let's make this equal, 8 newtons, and opposite reaction. My answer is 8 newtons. Newton's third law tells me. Let's keep going. Says here though, if you hit a nail with a hammer, the action force is the hammer hitting the nail. Okay, the hammer hitting the nail. The reaction is going to be the opposite. It's going to be the nail hitting the hammer would be the reaction. This would be the action, which would be 1, 2, 3. The reaction is the same thing but flipped it. 1, 2, 3. Now let's find the correct answer. The correct answer would be the nail hitting the hammer, and here it is. Let's keep going. If an object is moving at a constant speed, okay, with a frictional force, and a frictional force is applied opposite to the direction of the motion, the object will slow down. An object in motion will stay in motion unless an outside force causes a change. Newton's first law tells me that this is going to slow down because of friction. Okay? If a force increases and mass remains constant, then the acceleration of the object would do what? If I'm going to apply more force to the same object or the same mass, then the acceleration is going to increase. Again, we can do our math equation and we can do a comparison. We can say F equals ma. F can be 1, m can be 2, and a can be a, because we're going to solve for it. Divide by 2, divide by 2. Now if we're going to increase the force, well, let's just increase it by 2. And we're going to leave mass the same, 2. And we're going to solve for a. Divide by 2. Divide by 2. This answer comes out to 0.5. This answer comes out to 1. What happened? It increased. From here to here, it increased. And we were able to mathematically see that comparison. Match the following magnitudes with the correct answer about a man on the moon versus Earth. If the gravity of Earth is 6 times larger than the gravity of moon, determine the following. It says here for a 198-pound man. Well, in this case, we're definitely going to need our calculator out, right? First thing, I know that I don't use pounds, so I definitely need to make sure that I'm ready to convert that. And so to do that, I'm going to get 198 and divide by 2.2. So that's the first step, is that we've got to get rid of this 198 pounds. So 198 into my calculator divided by 2.2 comes out to 90, and this is kilograms, okay? So we're looking at 90 kilograms. What is the SI unit kilograms? What does that mean? That stands for mass. So this is the man's mass. What is the man's mass on Earth? Oh, look, we got that right here. 90 kilograms. What is the man's weight on Earth? Now, weight is due to gravity. And I know that if I got a 90 kilogram man and I multiplied it by the gravity of Earth, 9.81, I can find his weight force here on Earth. So 90 multiplied by 9.81 comes out to 882.9 newtons. So 882.9 newtons. Now what is his mass on the moon? Remember, mass, let me come over here, never changes. So his mass then on the moon is also going to be 90 kilograms. It's not going to change. It's the same. But what is the man's weight force on the moon? And don't forget, weight is due to gravity. And because the moon is smaller than Earth, how much smaller? It says right here, 6 times. Me personally, I'm going to go ahead and get 9.81 and divide it by 6. Let me find the gravity of the moon. So 9.81 divided by 6 comes out to 1.635, right, meters per second square. And that's the moon's gravity, acceleration of gravity. So now I'm going to go ahead and get his mass again, which is 90, no matter where he's at, multiplied by the moon's gravity, which is 1.635. And I get the answer of 147.15 newtons. And so that would be his weight force on the moon. Why? Because the moon's gravity is less than the gravity here on Earth. 6 times less. Okay? I mean, we can just literally got this number and divided by 6 and get the same answer. Okay, for those of you who are like great at math and you get that concept, maybe that's a little faster for you. Okay, if you just got this number divided by 6, you would get the same answer here. Okay, let's keep looking, keep going. Next part here says, if mass increases and force remains constant, well then what actually happens to the acceleration? Again, mathematically, we can go ahead and work that out. So we're going to use the equation F equals ma. Okay, and it says here that if mass increases and force remains the same, question mark acceleration. So let's go ahead and do that. Let's give force a number. We're going to call it 1. Let's give mass a number, an easy number, 2. And a is my unknown variable. Divide by 2, divide by 2, a equals 0.5. Now what happens here if I do the changes? It says here for force, let's keep it the same. If it's 1, let's keep it 1. For mass, let's increase it. Okay, originally it's 2, so let's just increase it to, let's just double it to 4. And then a is still my unknown variable. Divide by 4 to cancel, divide by 4, a equals 0.25. So what happened between the two numbers? They decreased. Okay, they decreased. And again, mathematically, they did not give me numbers, but I can plug in my own numbers, make them simple, go ahead and do the math. And I had to do it 2 times because of comparison. I had to get a base number and then I had to compare it. Okay, and I know you can do that. We've talked about it already. We've practiced it. Here it is again. It says here, which one of the following force diagrams could represent a skydiver that's accelerating downward? If that is the applied force, the stronger force downward, then that needs to be the biggest arrow. The correct answer was A. Using Newton's 3 laws, which one of his laws for all 6 of these? When you put a book on a table, gravity pulls down on the book and the table pushes up. So this is the 3rd law. A person leans on the wall and the wall pushes back. 3rd law. A brick sits on a table until you push it. So an object at rest will remain at rest. 1st law. Those dishes will remain at rest as long as no forces affect it. So if this person's able to pull that tablecloth fast enough, then those dishes will stay wherever they're at. The 1st law. This elephant is too heavy to push. It has too much mass. You need a stronger force to cause it to accelerate. 2nd law. The person's pulling this buggy with 1 object, but now they're trying to pull it with 4 objects. It's a lot heavier, okay? So they need more force to apply to this object to cause it to accelerate. 2nd law. Next one. We're down to the last 3 questions, and then we're done. If a 544 kilogram car exerts a force of, well, that's mass, 2.4 times 10 to the negative 8th newtons force on Amy, who has a mass of, here's Amy's mass, how far apart, question mark distance, is the car from Amy? Make sure you use the correct SI units. I went back and double checked everyone's answer values and the SI units, and I gave you back your points if you've earned them. Okay, so let's go ahead and let's do this. We are going to use Newton's gravitational acceleration equation. So in that case, then you're gonna need his gravitational equation to go along with it. I have his gravitational equation over here. Newton's gravitational equation, which is right here. F sub big G equals big G M1 M2 divided by distance square. So let me go ahead and just write that down. F sub big G equals big G M1 M2 over distance square. Let's don't forget that the big G is a constant number, which is on our formula chart over here. 6.67 times 10 to the negative 11. Mass, what's the mass of the first object? 544. What's the mass of the second object? 52. What is the distance between them? I don't know. But they gave me the force number, which is 2.04 times 10 to the negative 8. Could I put this into the triangle? You absolutely could. Cover up the equal part. This right here is being divided, so distance goes at the bottom, G M1 M2 goes at the top, and then F sub G. What are we looking for? The distance, and this would be my equation. Or we can algebraically multiply and rearrange it. So I'm going to go ahead and multiply this side by d squared, cancel. Multiply this side by d squared. I still need to get d squared by itself. So if I divide by 2.04 times 10 to the negative 8, that cancels. Divide by 2.04 times 10 to the negative 8. Now let's go ahead and let's do this. The number one problem that I did notice, if you got it wrong, was that some students did not use parentheses. Open parentheses, 6.67, second key comma to the negative 11th power. Close parentheses. Multiply, open parentheses, 544, close parentheses. Open parentheses, 52, close parentheses. Okay, I'm going to come down here and rewrite my numbers. 1.89 times 10 to the negative 6 over 2.04 times 10 to the negative 8. Again, you must use parentheses for the calculator. I mean, I'm not just sitting here preaching it and saying it for my health. I'm saying it for you. So open parentheses, 1.89, second key comma to the negative 6. Oops. I typed in the wrong. 1.89, second key comma, negative 6, close parentheses, divided by, open parentheses, 2.04, second key comma to the negative 8, close parentheses. I end up with 92.65 meters. Okay, and that's how I solved it. Again, I will take a picture and post that. Maybe that's a little easier to look at. Let's go to the next equation. It says here that your bicycle has a mass of 9,100 grams. And if you start from rest, VI is 0, and over a time period of 2.2 seconds, t, your velocity becomes 4.2 meters per second square, V sub F. What is the force that the bike is exerting? Question mark F. Okay, so F equals MA. I'm actually looking for F. I have the mass, but there's a problem. We need to do a step 1. 9,100 grams is not the correct SI unit. I need to convert that. How am I going to do that? King Henry drinks utterly delicious chocolate milk. And let's convert it from grams, which is the base unit, to kilograms. How many places? 1, 2, 3. The decimal is invisible behind the last 0. Let's move it over. 1, 2, 3. 9.1 kilograms is the actual number that you should have used. Many students miss this question. So let's put 9.1 times step 2. Let's solve for acceleration. A equals final velocity minus initial velocity over t, or final velocity is 4.2, initial velocity is 0, the amount of time was 2.2. Okay, again, I'm not looking for a negative value. Acceleration comes out to 1.91. Multiply that by 1.91. So 1.91, multiply that by 9.1. Oh, I like those numbers. Those are pretty cool. F equals 17.37 newtons of force. And that's how you solve this problem. Okay? Please, you're going to have to take the time yourself to go over the questions on the video and then ask me in class. But I can't help you if you don't go over them first. Last question. As a balloon flies through the air and exerts an upward force of 112 newtons and experiences a downward force of 76 newtons, as it continues to fly, there's an east breeze of 224 newtons with an air resistance pushing against it of 87 newtons. What is the overall net force? That means that there is two-part answer. They are looking for the magnitude, which is the number value, as well as the theta, which is the direction. First thing, for me, I'm going to look at my horizontal component. Second, let me look at my vertical. I mean, you can flip it either way. You need to look at the components separately, the X and Y axis. So let's look east and against it. So 224 take away 87. Up and down is going to be 112 take away 76. Again, I just put the bigger value in because I'm not looking for a negative answer at all. I just want the difference. 137 and then 112 take away 76 is 36. Okay, so now let's look at this one. Up is 112, down is 76. My winner is up. Now let's look at this. East versus the opposite. East is my winner, which is to the right. So overall, my balloon is going to move in this direction. My next step is to go ahead and look at this like this. And I can see if I start on the x-axis and go upwards, there's my theta. I'm looking for the theta and I'm looking for the magnitude. This right here, look at this, produces a right triangle, 90 degrees. Let's label it. Go to the opposite side of that right triangle. That's my hypotenuse. The theta and right angle is my adjacent. Left over is my opposite leg. So step 3 would be draw it out. Draw it out and label it. Okay. Now let's go ahead and go to step 4. We're going to SOHCAHTOA. SOHCAHTOA. And find the theta. Let's do that. Well, what do I have, or what was given to me? Let's see. I've got horizontally 137 and vertically 36. So I have the A leg and the O. Okay. Who is A and O? The tan. So the tan of the theta equals the opposite over the adjacent, or 36 over 137. So 36 divided by 137 comes out to 0.26. That is not my answer. I need to get rid of that tan so I can just get the theta by itself. So to do that, I need to do the inverse of tan. So second key tan, 0.26 close parentheses, the theta equals 14.57 degrees. Okay, we're not done. We're going to call this now step number 5. And step 5 is going to be Pythagorean. So I can find the magnitude, which is the size of that arrow. So in this case, let's go ahead and do that. 137 squared plus 36 squared equals c squared. So 36 squared, 1296, 137 squared is 18,769. I'm going to add those two numbers together. $200.65. Not my answer. This is a square. So let's go ahead and do the opposite, which is square root it. So second key square, 20065, actually comes out to 141.65. What are those vectors? This is a Newton and that's a Newton. So my answer is going to be in newtons. There we go. So now I've worked out every problem on the quiz. Okay, there should be no reason for you to not know what the correct answer is. You just need to either watch the video or go back and look at the pictures from the answer key that I'm going to post. Okay, other than that, have a great day.